Hello students, today I am going to show you how to prove a given number is irrational. Before I start, I want to give you two informations. First, that this video is also available in Hindi, so anyone who is comfortable learning in Hindi can click on the link here and watch this video in Hindi. Second one, that I am going to use a lot of concepts from my video number system in mathematics, such as real number, rational number, irrational number, composite number, prime numbers. So anyone who is not familiar with these concepts, please click on the link here, watch that video first and then come and learn this concept. Alright, so now we will proceed further into the proof. So before I start proving that a number is irrational, we are required to learn one theorem. So why don't we start learning the theorem right away? So here it is. As you can see on your screen right now, the theorem says if any prime number p is a factor of a composite number c square, then the number p must be a factor of the number c. Now let us try to understand this theorem with an example. Let us say that 3 is a factor of 21 square. Then according to the theorem, if 3, which is a prime number, if it is a factor of composite number 21 square, then it must be a factor of the number 21 itself. And 21 is what? It is the base number of 21 square, right? So mathematically, if you want to see, then if we factorize 21, what we get? We get 3 into 7. So clearly 3 and 7 are the factor of 21. Now what happens when we factorize 21 square? So when we factorize 21 square, the factors of 21, which is 3 and 7, they get squared and we get 3 square into 7 square as the factor. But still the factor of 21 square remains the same. 3 and 7 are the factor of 21 square. So what do we understand from this theorem? That since the base number remains the same, here in the example, the base number is 21. So since the base number 21 is same, the square of 21 also has the same factor as the base number, right? The opposite of this theorem is also true. Let us say if p is a prime factor of the composite number c, then p is also the prime factor of a composite number c square. What we are doing here? We are just squaring the base number, which is c. So for example, in the current case, if 3 is a factor of 21, then 3 will be a factor of 21 square also. And this is a common sense problem. This theorem is related to common sense, right? So now I hope that you have understood this theorem and we are ready to prove that a given number is irrational. So let us say we have to prove that root 7 is irrational, right? So let us prove that root 7 is irrational. What will be our first step? Our first step will be to assume that root 7 is not irrational, but it is a rational number. So let root 7 is rational. Since root 7 we have assumed as rational, we can express it in the form of p by q. So we will do the same. And here p and q are integers where q not equal to 0. So those who are aware of how to express rational number, they are already comfortable with this concept, that why I have written that p and q should be integer and why q should not be equal to 0. Those who are not aware, I tell you once again that go and see that video on number system and then watch this proof. Otherwise you won't understand a lot of things. Now what will be the next step? Here p and q may have so many common factors. So our next step is to cancel out the common factors in numerator and denominator and simplify this fraction p by q. So we will cancel out the common factors in numerator and denominator and we will simplify. Let us say after simplification we get root 7 is equal to a by b. Now here, if you remember, I told you the simplification of a fraction stops when in numerator and denominator we get two numbers which are co-primes to each other. So here, since we have simplified P by Q and we have obtained A by B. So A and B must be co-primes to each other, and they have only 1 as common factor, right? So next step is to square right hand side and the left hand side. So we will square both sides, right? So root 7 square is equal to a by b whole square. After squaring, the root will be removed and we will get 7 is equal to a square divided by b square. Now we will simplify it and we will get b square is equal to a square divided by 7. And let us say this is equation 1. Now guys, I want to tell you one thing here, that you can clearly see that b is an integer. So b square also has to be integer, and which means that when a square is divided by 7, we are getting an integer, and when we get an integer in a division, then we say that it is a perfect division and the divisor is a factor of the dividend. So here divisor is 7 and it must be a factor of a square. So now the next case will be that since b square is an integer, this means a square is perfectly divisible by 7, which means 7 is a factor of a square. Now just now we have learnt a theorem that if p is a prime factor of c square, then p is also a prime factor of c. Here also if 7 is a prime factor of a square, then 7 has to be a prime factor of a only. So the next statement will be like this, that as per earlier theorem or as per the theorem, 7 is also a prime factor of a. Now since 7 is a prime factor of a, we can express a in the form of 7 and other factor k, where k should be an integer, right? Now remember that in the previous slide we have written equation 1 as b square is equal to a square by 7. Now this value of a is equal to 7k we will put in equation 1, and after putting that in equation 1 we will get b square is equal to 7k whole square divided by 7. After simplification, what we will get? We will get b square is equal to 7k square. In the previous equation where 7k square divided by 7 is there, the denominator, the 7 in the denominator will cancel 1 7 in the numerator and 1 7 will remain. So that's why b square is equal to 7 into k square. Now next step is what? We will simplify and we will get b square by 7 is equal to k square. Now once again you can see that since k is integer, we have clearly written here that k is an integer. Since k is an integer, therefore k square has to be an integer, and when we are dividing b square by 7 we are getting an integer value. This means b square is perfectly divisible by 7, right? And hence 7 is also a factor of b as well as b square. Why? According to theorem, if 7 is a factor of b square, then 7 has to be a factor of b. Now guys, just now we saw that 7 was a factor of a and a square, right? Now again 7 is a factor of b square and hence b. So 7 is a common factor of a as well as b. But do you remember that we have written that a and b are co-primes? So other than 1, can they have any other common factors? No. It is completely a contradiction, right? So we have to write it that since 7 is a common factor of a and b apart from 1, this means they cannot be co-primes to each other. And if they are not co-primes to each other, there arises a contradiction in our proof. And why this contradiction is there? This contradiction is there because our assumption that root 7 is rational was wrong. Yes, since we have assumed a wrong statement that root 7 is rational, therefore this contradiction is coming. Hence, we will conclude here that root 7 is not rational, it is an irrational number. So our proof ends here, right? So in a very proficient way, we have proved that our number root 7 is irrational. Alright guys, so hope you understood that how to prove that a given number is irrational. Now let me give you a tip that root of any prime number is irrational. Yes, you take the root of any prime number, that number will be irrational. Let us say, for example, if you take the root of 2, so root 2 is irrational, root 5 is irrational, root 11 is irrational. Any prime number you remember in your mind or it comes to your mind, you take the root of that prime number, that will be irrational. So if next time in your examination, if a question comes that prove that root of a prime number is irrational, just follow the rules which I have taught you right now and you will get 100% marks. Now guys, I have two questions which I want to ask, right? So can you tell me that whether -2, -5, -11 or -19 are these prime numbers? If yes, then why? If no, then why? You have to prove it. Second question, that set of four numbers, let us say -5, -7, -9 and -11, are they co-primes to each other? If yes, how? If no, why? And if you have any difficulty in solving these two problems, then do not hesitate to ask me. You can write your question in the comment section and I will reply it by making a new video. Alright guys, so since in this video I have concluded this chapter on prime numbers, so from next video I will solve previous year's question paper on the topic real numbers. So make sure you watch my next video, and for that you have to subscribe to my channel. So make sure you subscribe to my channel. And guys, if you think that you have understood or if you have learned a very important topic today, then please give this video a thumbs up and also share this video with your friends, because sharing is caring. They will appreciate your efforts, right? So I will see you in my next video. Till then, please keep practicing and take care of yourself. Bye bye. See you next time.